Good morning, guys. Welcome to today's lesson, May 19th, super factoring. What in the heck does that mean? We will find out, but let's first take a look at the do now. We have a nice trinomial, x squared plus 4x minus 12. Nice standard AM. What two integers are going to multiply to negative 12 and are going to add to 4? That would be, hopefully you're thinking about it or pausing the video, a positive 6 and a negative 2. And remember, we just throw our x in front now. So we have x plus 6 and x minus 2. Can you factor anything else further? The answer is no. You're all done. All right, remember a quick check. X times x gives us x squared. 6 times negative 2 gives us negative 12. And that will be useful today when we talk about superfactoring. All right, next, 3x squared plus 8x plus 4. This would not be an example of AM because the value in front of x squared right now is 3, right? We know that a right now is greater than 1. So that's where we're going to get into our AC factoring. And of course we checked for GCF first. There is no GCF, but multiply a times c, which is 3 times 4. 3 times 4 is 12. So we need to know, hey, what multiplies to 12 and what adds to the b value, the value in front of x, of 8. What multiplies to 12 and adds to 8? That would be 6 positive and 2 positive also. Alright, so we open up our two parentheses. We'll have our positive 6 and our positive 2. And remember what we throw in front of these values now? Not just x, right? We need the a value with x, so it would be 3x and 3x. Remember, we could break one or both of these now one or more of these down at this point. Okay, you can see the first value, the first factor, 3x plus 6. You can divide those by a common factor. Right, so you can divide both of those by 3. In this case, this is not your regular GCF factoring. You don't throw the 3 out front of the parentheses. You just write your simplified form here. This would give us 3x divided by 3 is x. 6 divided by 3 is 2, so we have x plus 2, and still that second factor of 3x plus 2. And now you're done. There's no dots or anything or GCF that's left. We're good to go. Alright, next. Now we see 4 terms. Typically we would think grouping. Alright, just check for GCF first. Is there a common factor for all 4 of the terms? There is not. Okay, so we're going to break it up into 2 groups. Alright, so what's the GCF for the first group? For x cubed plus 5x squared, the GCF will be x squared, so we can divide both here by x squared. X squared gets thrown out front of the parentheses. X cubed now divided by x squared, which is x. 5x squared divided by x squared is just 5, so plus 5. Alright, and now we need our GCF for the second group. Negative 4x minus 20. Remember we talked yesterday about that third term? Right, if that third term is negative, typically we're going to divide out a negative value. So you might be thinking here, okay, we could divide out a 4 for 4x and 20, but we're going to divide out a negative 4. Because remember, guys, in these types of problems, we need that common expression, we need that common factor in the parentheses after we divide. So if we divide by negative 4 throughout, we have minus 4, GCF out front, open your parentheses, negative 4x divided by negative 4. The negative 4's just cancel out. We're left with x. And now negative 20 divided by negative 4 is positive 5. Notice how we got that common expression, that common factor in the parentheses. If you were to divide out a positive 4 there, you wouldn't have ended up with x plus 5 for both. Alright, so with grouping, I really want to emphasize this today. With grouping, you need that common expression in the parentheses. So your GCFs get a set of parentheses, and your common expression here gets another set of parentheses. Are we done? Hopefully you picked up on it. We're not done. This first parentheses here, x squared minus 4, is a classic example of dots. X squared is a perfect square rather. All right, and 4 is a perfect square. So you would break that up, right? X times x gives you x squared. 2 times 2 gives you 4. One of your signs is positive, and one of your signs is negative. And remember where that's right here, dots. Okay? And don't forget about that factor on the end here, x plus 5. And now you're good to go. So always be looking out at the end. Are you done? Are you definitely done? Is there an example of GCF left, or dots, or something like that? All right. All right, so AM, right? We took a look at this exact problem in the do now. X squared plus 4x minus 12. All right, we factored it out to x plus 6 and x minus 2, right? We already did that one. Now, with super AM, all right, it's a very, very similar looking problem. All right, you see we have x to the 4th power plus 4x squared minus 12. All right, guys, the good news is it's basically the exact same thing. All right, we need factors when you have this sort of setup with x to the 4th and then something x squared. We still need to be thinking about AM in terms of we need factors of negative 12 that are going to add to 4. And why is that? Because remember what's in front here. You still have a 1 in front. That tells you we're working with AM. Just like over here, the value in front was 1. All right, so you're still thinking about AM. Now, the factors. It's the exact same factors as the problem to the left. Positive 6 and negative 2. Because they have to multiply, right? 6 times negative 2 is negative 12. And they need to add to 4. 6, all right, plus negative 2 is 4. Now, if we were to put, like our normal AM here, if we were to put x and x, and we multiplied those, right, x times x, does that give you x to the 4th power? The answer is no. Okay, so we have to do something different. We have to think what times itself, right, what times what is going to give me x to the 4th power? Because x times x gives me x squared. That's not good enough. We need x to the 4th power. All right. So once again, think about that. If you didn't answer that in your head right now, what do I multiply? What times what gives me x to the 4th? The answer is x squared. All right. And you could check that, right? If we used, let's just do the box method real quick. I want to definitely show you how this works. If we were to say x squared plus 6 and then x squared minus 2, watch how this multiplies out. X squared times x squared is x to the 4th. Remember adding exponents. Negative 2 times x squared is negative 2x squared. 6 times x squared is 6x squared. 6 times negative 2 is negative 12. Like terms. So we have x to the 4th. Now we're going to do these like terms right now. 6x squared minus 2x squared. That would give you 4x squared. And you still have minus 12. So you can see that, guys, this brings you back to the original. So you could check it out with the box method. Now, when these exponents go in a 2-to-1 ratio, that's sort of the mathy way to think about it. What times what is going to give me x to the 4th? All right. Anytime, guys, we're working with these exponents sort of in a 2-to-1 ratio, like it goes from 4 to 2, and you're working with AM, if it goes to 4 to 2, those exponents are going to be 2. Okay, you can think about it, it's always going to be that second exponent. They're both going to be x squared, or it's going to be half of the first exponent, which is 4. So 4 and 2, exponents are 2. Even over here, we haven't really thought about this necessarily like this yet. That exponent is 1, and these exponents are 1. So it's the same idea. If the exponents are going from 2 to 1, right, our exponents are going to be 1. It's that second exponent, right? The second exponent is 1, so they both get 1 in your factors. Okay, or you could think about it, it's half of the first exponent. The first exponent is 2, half of that is 1, so 1 and 1. All right, so once again, here over to the left, it was 2 and 1, the exponents are 1. This one's 4 and 2, the exponents are 2. Okay, even with something crazy like this, now would be a good opportunity to pause the video and try this out. All right, our value in front here is 1, and it's a trinomial, so we're thinking about AM. So what are our factors of our factors of 6 that add to 7? Factors of 6 that add to 7. What are those? It would be positive 6 and positive 1, right? Because if we were to do 6 times 1, that gives us 6. And if we were to do 6 plus 1, that gives us 7. So standard AM, guys, nothing different at this point. All right? What multiplies to 6 and what adds to 7. Now the question is, what do we put in front of this 6, in front of the 1? Okay, it's going to be x to something. What should that something be? It's going to be the exact same value as that second exponent. So it's going to be 7 and 7. So you can think about it like that. Because x to the 7th times x to the 7th is x to the 14th when you add the exponents. Or you can think about that first exponent here of 14, and you got to cut that in half. All right, divide that by 2, and you get 7 and 7. All right, so this is done. This is just AM. It's super AM, right? But there's really just one additional step. You need to be strategic about what x to what value, x to what exponent, what should we be using? Okay, so those are a couple of different ways you could think about it. All right, and check your answer. Box method, GeoGebra, whatever. All right, you can see that you did it correctly. Okay, next, what do you notice about the exponents in each problem? All right, so once again, that's an exponent of 1, so it goes from, the exponents go from 2 to 1. It's sort of like that 2 to 1 ratio. Same idea here. Okay, they go from 8 to 4. That's the same ratio. Right? The exponents are basically getting divided by 2. All right. So this problem we already did, right? In our do now today. 3x squared plus 8x plus 4. And what did we get? 3x squared plus 8x plus 4. We ended up with x plus 2 and 3x plus 2. Now this looks over to the right, this looks like the exact same problem. 3x to the 8th plus 8x to the 4th plus 4. However, instead of going from 2 to 1, we go from 8 to 4. But it's still the exact same idea here. Our answer can't be x plus 2, 3x plus 2. Because if we were to take this, guys, x times 3x, does that give us 3x to the 8th power? No way. Okay, that would just give us 3x to the 2nd power. So what would our exponents need to be? We don't need to go through this problem all over again, guys. We just have to be strategic with our exponents. So x to what power? And 3x to what power? It's going to be the same exponent. All right, but it's going to end up being 4. X to the 4th and 3x to the 4th. Because now if we go do that, x to the 4th times 3x to the 4th, right? That would be 3x to the 8th. Add the exponents, and you would see you would end up with the same, the original expression. So you're done. So once again, it goes from 8 to 4, the exponents are 4. These ones go from 2 to 1, the exponents are really 1, right? X to the first, 3x to the first. All right. So once again, it's really, there's sort of like a trick in this. That second exponent, which is 4 here, right? That's what the exponent is going to be for each factor. Or, once again, you could think about the first exponent. The first exponent is 8. You just divide that by 2 to get 4 and 4. All right? So it's something that's new. All right, but really just one extra step. So now we're working with a polynomial with 6 terms. Is it 2 groups of 3 or 3 groups of 2? All right, remember, now this is going to be a grouping problem because there's so many terms, right? There's 6 terms. Remember, with grouping, what are we saying to do now? We have to make sure, see those x plus 5s? We have to make sure we get a common expression, a common factor in those parentheses. So in this one we got x plus 5, x plus 5. You could really check with both. You could do 2 groups of 3 or 3 groups of 2, and you'll see for one of them, you're not going to end up with the same thing in parentheses. If you're factoring by grouping and you didn't get the same thing in parentheses, you really got to think about trying it again. But in this case, when we do it with 2 groups of 3, let's see what happens. So from the first set of parentheses, what would our GCF be? X cubed plus 3x squared plus 2x. What could we divide everything by? What would that GCF be? That would be x. Divide all 3 of those by x. They all have at least x to the first power in common. So x outside the parentheses, x cubed divided by x is x squared. 3x squared divided by x is 3x. 2x divided by x is 2. Now your GCF for the next group, 3x squared plus 9x plus 6 would be 3. So divide each by 3. So plus 3 out front. What would go in the parentheses? 3x squared divided by 3 is x squared. 9x divided by 3 is 3x. And 6 divided by 3 is 2. Notice how we ended up with that common expression, that common factor in the parentheses. Okay? I challenge you to go back and break it up into 3 groups of 2 and start dividing out, and you're going to see that you don't end up with the same thing in parentheses. Alright? But now, remember, we're not done. X plus 3, the GCFs, get a set of parentheses, and the common expression there also gets a set of parentheses. Now, are we done? Not quite, because we have standard AM factoring left. That's a nice trinomial that can be factored with AM. X plus 3 stays out front. Now, what are the factors of 2 that add to 3? Just 2 and 1. And now x you throw out in front. And just keep in mind, alright, it's standard AM factoring, you just get that second exponent. That second exponent is 1. These are getting x to the first power. If it was something like 4 and 2 for those exponents, then we would end up with the exponents to be 2. If it was something like 6 and 3, those exponents would be 3. If it was something like 8 and 4, it would be 4 and 4. That was really the point of today's lesson with the Super AM. Alright? But that was just standard AM that we've been doing for quite a bit of time. Now we're done. We make sure we factor completely, and you're good to go. Alright, guys? Your Delta Math is posted. Please make sure you're getting familiar with those Delta Math topics, because your final exam is going to be through Delta Math. It's going to be a longer assignment, Okay, you'll have an extended amount of time to do it. Okay, but it's going to be those same topics. So if you're good with those topics now, you're good for the final exam. If you're not good with those topics, all right, you should be paying more close attention to these videos, but also, guys, message me and remind, ask a question. All right, because once again, these same topics you're getting on Delta Math, you will also be getting on your final exam. The final exam is through Delta Math. All right, that's it. Please ask questions if you have them. Get the Delta Math done, get it out of the way. Due at Thursday, 8 o'clock. Have a wonderful rest of your day, and I'll see you mañana.